What is exactly the observable universe? The observable universe refers to the portion of the universe that we can observe and study using telescopes and other instruments. However, this capability is limited because light, the main source of information about the universe, can only travel at a finite speed. As a result, we can only observe objects or events that are at a certain distance from us. We cannot directly see objects or events that occurred long ago in the past. The diameter of the observable universe is estimated to be approximately 93 billion light-year, which is much larger than the estimated age of the universe, which is estimated to be 13.8 billion years. This discrepancy is because the expansion of the universe has caused objects that were once close together to move away from each other, and light from those objects has required more time to reach us. Overall, the observable universe is a vast and fascinating space, but there's still much we don't know about it. However, through the use of telescopes such as NASA's James Webb Space Telescope and other scientific instruments, we continue to learn more about the structure, composition, and history of the universe, as well as its various phenomena. Join us as we discover the NASA structure that the James Webb Space Telescope has just made contact with in the far reaches of the observable universe. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. Now, what lies beyond the observable universe? To reach the far reaches of the observable universe, we would need to develop transportation methods that would allow us to transcend spacetime, such as using distortion engines or wormholes. These concepts have long been the subject of debate among scientists, some of whom believe that these are simply impossible or that they contradict the idea of faster-than-light-speed travel. The feasibility of both possibilities, faster-than-light travel, and the use of advanced technology beyond the reach of current human intelligence, is a subject of intense debate. Even if it were theoretically possible, it would require technological advances and machinery that are currently beyond our capabilities. The theory of cosmic inflation posits that the total size of the universe is at least 10 to the power of 23 times larger than the observable universe. This number is so vast that it is incomprehensible to the human mind. Since we cannot see or measure the unobservable part of the universe, we have no way of knowing with certainty what lies beyond its limits. However, that does not mean we cannot develop theories based on the information we have gathered from distant galaxies. And this is where NASA plays an important role. NASA, in collaboration with other space agencies and research institutions around the world, has made numerous significant contributions to our understanding of the universe. Even before the James Webb Space Telescope became operational this year, NASA had already released images of the ultra-deep field obtained with the Hubble Space Telescope. However, when the James Webb Space Telescope made its debut, it was taken out to observe the most distant galaxy ever recorded. These images revealed the presence of numerous galaxies shining in the distant cosmos. Apparently, as they were millions of years after the Big Bang occurred, approximately 13.8 billion years ago. The expansion of the cosmos causes the stretching of light to redder wavelengths, which allows the James Webb Space Telescope to detect infrared light. This has allowed us to observe galaxies forming in the early stages of the universe's history. The James Webb Space Telescope has made observations of several fields of distant galaxies, allowing scientists to study the rate at which stars formed in the early universe. This data revealed the existence of a significant population of galaxies that were forming stars in the early stages of the universe. These discoveries are truly fascinating and thought-provoking. For a long time, humans have contemplated the possibility that we're not alone in this vast universe. However, these new determinations within the observable universe lead us to believe that there must be millions of galaxies in the unobservable part of the universe. This idea is truly shocking and awakens a sense of awe and wonder about the vastness of the cosmos. Are there extraterrestrial beings somewhere in the universe? The likelihood of life beyond Earth has never been more compelling, leading us to consider the possibility of the existence of extraterrestrials. There are numerous planets outside our solar system known as exoplanets which have been discovered using techniques such as the transit method and the radial velocity method. Some of these exoplanets may have similar characteristics to Earth and may harbor life. This theory has been supported by another discovery made thanks to the James Webb Telescope related to the exoplanet WASP 96b. This planet is outside our solar system and its light spectrum reveals something surprising. the presence of water molecules. In addition, the spectrum also shows hints of haze and clouds which were not previously thought to exist on a habitable planet. Based on the habitable environments found elsewhere in the universe and considering the advances in the search for exoplanets, it is difficult to rule out the possibility that alien beings exist beyond our planet. Although we do not yet have conclusive proof, discoveries and evidence suggests that the existence of extraterrestrial life is a fascinating possibility. What about the multiverse in relation to the vastness of the observable universe? Let me tell you, the possibilities are endless. The concept of the multiverse, also known as the many worlds interpretation, is a theoretical idea in physics and philosophy that suggests the existence of multiple parallel universes or dimensions beyond our own. The multiverse is mainly discussed in the context of quantum physics, which deals with the behavior of tiny particles such as atoms and subatomic particles. According to some interpretations of quantum physics, the act of observation can cause a quantum system to collapse into a single state. However, in the many worlds interpretation, the act of observation simply causes the system to split into multiple states, each representing a different outcome. It is important to note that the idea of the multiverse remains highly speculative and is not yet supported by conclusive evidence. It is therefore difficult to state with certainty whether it is a valid concept or not. Some scientists and philosophers find the idea of the multiverse intriguing and potentially useful in explaining certain phenomena, while others are skeptical about its validity. Given that we do not know what lies outside our universe, the possibility of the existence of a multiverse remains as valid as the famous Schrodinger's thought experiment or the nature of darkness. It is a concept that arouses fascination and reflection but requires more research and evidence to be confirmed. Does the phenomenon known as dark flow exist? The question is complex and raises an intriguing issue. Dark flow came about in 2008 as a possible explanation for the observation that some galaxy clusters appear to move faster than expected based on the distribution of matter in the universe. The concept of dark flow suggests that these galaxy clusters may be influenced by some form of dark matter or dark energy that pulls them in a specific direction. However, the existence of dark flow remains controversial and has not yet been accepted by the scientific community at large. Some studies have suggested that dark flow may be real and could be caused by the presence of a massive structure in the universe that exerts an attraction on galaxy clusters. However, other studies have failed to confirm the existence of dark flow and have proposed that the observed motion of galaxy clusters could be the result of other factors such as systematic errors in the detected ones. While other studies suggest its possible existence, we cannot say with certainty it's present outside the observable universe. More research and evidence are needed to better understand this intriguing phenomenon. What do you think? Let us know in the comments box. Remember to like and subscribe, and see you in the next video. The limit of the observable universe is defined by the cosmic light horizon, the maximum distance from which light has had time to reach us since the Big Bang. This isn't a boundary of the universe itself, but rather a limit to our observation. Beyond this horizon, the universe may continue indefinitely or it may curve back on itself depending on its overall shape and structure, which cosmologists continue to investigate. The cosmic microwave background, CMBB, a faint glow left over from the Big Bang, marks the farthest back in time we can observe using electromagnetic radiation. It offers a snapshot of the universe when it was only 380,000 years old and remains a crucial piece of evidence for the Big Bang theory. Eventually, if humanity overcomes the massive technological challenges, we may attempt interstellar travel. Concepts like fusion propulsion, antimatter drives, or the Breakthrough Starshot initiative, which aims to send small spacecraft to nearby star systems using light sails propelled by powerful lasers, represent the early seeds of this dream. Even more speculative technologies such as warp drives or Einstein-Rose and Bridges wormholes are being explored in theoretical physics. While many of these remain in the realm of science fiction, they reflect humanity's innate desire to reach beyond the stars and find our place in the universe. The observable universe, vast as it is, might only be the beginning of a much larger reality. Imagine for a moment that everything we've seen, every galaxy, star, and planet, is just a small fragment of a far greater cosmic structure that lies beyond our perception. The light from those distant regions has not yet had enough time to reach us. That doesn't mean they don't exist. simply means we are not yet able to witness them. As we build more powerful telescopes and develop new detection methods, we are not just looking deeper into space. We are looking further back in time. Every photon we detect carries with it a story from the past, from a time when the universe was younger, more chaotic, and full of primordial energy. Each image we capture is not just a snapshot in space, but a relic of cosmic history. Yet, the universe continues to expand, and this expansion is accelerating. This means that some galaxies are being pushed so far away from us that one day their light will never reach us again. They will slip beyond our cosmic horizon and vanish from observable reality. We are in essence witnessing a slow fading of the universe's grand tapestry, an inevitable separation from regions we once hoped to explore. It raises a haunting question. Are we living in a shrinking bubble of visibility, a temporary window through which we can catch a glimpse of the universe before it drifts forever beyond reach? And while we seek to explore what's beyond, we must also come to terms with how little we understand about what's right in front of us. Dark matter continues to elude direct detection, making up most of the universe's mass, yet invisible to our instruments. Dark energy, even more mysterious, is the driving force behind the universe's accelerating expansion. But we don't know what it is or why it exists. All we know is that the more we learn, the more questions arise. Our pursuit of cosmic knowledge is no longer just about looking outward. It's also about looking inward at our own place in the cosmos, at the limits of human perception and imagination. We are a species with curiosity written into its DNA. And though our tools are imperfect and our reach is limited, we press on because somewhere out there in the darkness may lie answers to questions we've carried since the dawn of time. What sparked the universe into existence? Are we truly alone? What is space? And what is time? And could there be other realms, dimensions not bound by the physics we know, interacting with ours in ways we cannot yet detect? The observable universe is not just a boundary of light. It's a boundary of understanding. And as we approach its edges, we're reminded that the journey of exploration is endless. Every discovery leads to more mystery. Every answer spawns 1,000 new questions. But perhaps that's what makes it beautiful. Not the certainty, but the wonder. Not the destination, but the endless pursuit. So the next time you look up at the night sky, remember this. You are not just seeing stars. You are looking at time, at history, at possibility. You are witnessing the visible edges of a universe that might be infinite. One that still holds secrets we've yet to even imagine. And this is only the beginning.